In this video I'm going to set up and test the Sandevices E682 controller card and a combination with the Vixen software and the E1.31 internet protocol. And I'm going to flash some pixel test strands here. So the first piece of equipment is the Sandevices E682 card. I've got it mounted in a CG 1500 base. That's what they recommend, or one of the things they recommend, because the hole pattern, and you can screw it right down in there. They say that you can put a power supply in there with it, but you can see right here I've just got a DC 10 amp. This is 5 volt, and takes up a lot of the space, just 10 amps. I have a 40 amp sitting around here somewhere, and it basically takes up all the space. So I'm not sure whether, I'm pretty much sure I'm not going to I'll put a separate enclosure for the power supplies, because I'm just afraid they're going to get hot. You'll need quite a few amps to drive large pixel displays. But yeah, so you can mount it in here, and it will be weatherproof, and the wires go out the bottom. So this card is you buy it from Sandevices. It's not like an Amazon special, and there's a guy, I think it's Jim St. John or whatever, and it's $118 for just the components, and you can solder it yourself, or I went with the $189 assembled and tested. So it is quite an expensive item, so that's one of the reasons it's going to be outside, so I did put it into the waterproof box for it. So I know that's a very expensive and high-end controller, but if you look at systems like the Lightorama, I think it's about $700. I know they give you a controller for 16 channels, and they give you a bunch of other stuff. But you know, so in contrast to $700 for a little bit to get this going, $189 for a board with 16 channels is not too bad. And I think the guard, the case there, is about $40. So all in all, I think I'll be about $300 when I get in before I get into the pixels and some of the other stuff. So yeah. So attached to the card today, I've got these. I got 2 strands of 50 pixel. I just got them wired into a piece of cardboard and a piece of styrofoam. And the pixels themselves look like this. This pixel right here, they got a little circuit card. That's what makes them smart. Or an IC. There's one IC for every pixel bulb, and there's 3 diodes in there, red, green, and blue. And about these smart LED type lights, the nice part is you can control the intensity and color of every single pixel. I've got 50 to a string, 100 total. So I've got them in 2 strings, and you plug them into the board. There's 3 wires on these are 2811 type pixels, and there's 3 wires. There's a plus 5 volt, because these are 5 volt style, a ground, and then these just require a data line. And they plug into these little things that come with the board, and you're just going to snap them right into the slots. You can see I've got 2 of them. 2 strands of 50, so 100 total pixels plugged into the board. I also, over in a different zone over here, a different grouping. There's 4 groupings to this card, 4 of 4 each. It gives you 16 plug-ins, but you can extend a string longer than 50 or whatever you would want to do. I also got some of these are old, a lighting string. This is you get 1 IC and 3 diodes. It's this old Dream Chaser crazy light. I've had these for a few years on the outside of the house, and so that's there's 150 diodes in that string, but it's only 50 ICs. The length of that string is it's 5 meters or 16 feet. Each one of these pixels, you can order them in different styles and different lengths and configurations and wire colors, but the cheaper one here that I've got is about a 3-inch spread between the pixel bulbs, and the overall length for 50 is about 12 feet, or 100 is 24 feet. So that's about what these are, but you can certainly, either one of these, it's harder to cut apart. This one has a silicone outside, so I really don't like to cut it, because that's the water integrity, is the silicone outside. But these you could easily cut and splice to wider lengths. I'm sure you can order them, but it's all about pricing. This strip light, it doesn't really matter that it's 6083. That's the protocol that it drives. It is a few years old. Like I said, I had it on the house, but it's about about $30 for the 16 feet. And it doesn't matter if I went to 2811. I think I can find that's about the cheapest price. Certainly you can find them more expensive on Amazon, and people will charge up to $100 or more. But that's about the going rate, the cheapest you can find that I could find. And these pixel lights are $20 for 50 or $40 for 100. In the configuration that I got, that's about the cheapest I can find them. So they're quite pricey, both these strings. It's not like going down and getting a $5 leftover at your Kmart or Home Depot or something for Christmas lights. These are complex controlling lights. Like I said, these pixels that I ordered, they can be ordered, both these styles can be ordered in 5 volt or 12 volt. I happen to have the string was 12 volt, and I know that pulls for the 16 feet, it pulls 3 amps. So 3 times 12 is 36 watts is what it takes to drive that. So you need to have a 12 volt power supply that'll power that. And the pixel lights are 100 would be 6 amps. So on the 5 volt, so that's, again, if you do that math, for 100 of those, you'll be 6 amps times 5 volts is 30 watts. So you get a little longer or more pixels or whatever, but those are the going price. Again, these were 40 and 30 for that string, and you can string them together, or you can plug them into different modules on this guy. Power wise, it's kind of set up, there's 2 power zones on this. On the right hand side, the white wires going in are going back to my 5 volt power supply that I just showed you a little bit earlier. String it over here. This is one of these switching power supplies. This one is a 10 amp. Obviously, if I'm driving a lot of pixel LED, that'll handle the 6 amps that I've got hooked up right now, plus a little bit, because the right side of this E682 is power based. You can either put 12 or 5 on the right hand side. The jumper, there's a jumper in here you got to swap if you're going to use 5 volt. So I had to swap that jumper. The default that it ships to you is 12. There's a lot of documentation online to help you there. The other side is going to just a temporary. This is a 70 watt 12 volt. So that'll handle the 36 that are on there right now. And that plugs in. So the left for the two groups to the left, which are the first 8, are going to be on 12 volt in this particular case, and the right are on 5 volt. So you have to plug in those type of voltage pixels as you expand the system here. But it's kind of nice because it does allow you to have 2 different voltages should you have those type of strings hanging around. There's advantages and disadvantages between the 5 volt and the 12 volt setups. 12 volt, a little bit more expensive in that I could find for the cheapest price on the strips and the strings, but there's a lot more selection for the power supplies. 12 volt uses more power even in the string configuration than 5 volt. So 5 volt is a little more efficient in terms of total wattage in the system that you'll be pulling out of the wall. But 5 volt obviously suffers more voltage drop. It's more susceptible to thinner wires or lengths. So if you try to run extremely long lengths or a lot of pixels, you have to use more amperage, or you have to inject power further down the line. Or if you try to go a great distance from this card, that's in both. The 12 volt is a little more tolerant to distances than the 5 volt. But even the 12 volt, you might need to inject power at a different, as you go further away from the controller, because both of these systems don't like to go real far from the controller. So it's important this controller will be out in the yard. So again, that's why the weatherproof box. Other than that, you got a plug-in cable, an Ethernet cable. And I've got a big long Ethernet cable here. It's about 50 feet. That'll get me from where I'll be indoors. I also have the computer, and I used a switch just to connect the two. You can kind of direct connect them, or you can wirelessly connect them. I wired in, just a switch to get out there. So the computer is going to be indoors. It's going to play music. It's going to do the Vixen thing, but I'll stretch this out to the yard, and then the displays will be out in the yard. So it's important that you wire these. Again, this is a 4-wire for the. Just make sure you get your 12 volts and your ground, or your 5 volt and your ground outputs and inputs. Make sure they're all wired up correctly. The middle 2 in this one are a data on a clock line. This 6083 protocol requires data on a clock. The 2811, 2812 type protocol only needs the data line, so that's why there's 3 wires coming out of those. But let me go ahead and fire up this strip, and we get some lightage, we get some blinking lights over here. My hub is powering up, the two power supplies are up, so everything's off. I should mention that these strips are a little, after 2 or 3 years you do some bending. I do have one pixel or one IC system that's 3 lights that I obviously have a short in that IC, so I'm getting one color strand along this line. So this strand was kind of junk anyways, unless I go cut that out or colluge it. So it's a good thing I was testing with this, which is, I'm just doing that to show that the different protocols. So I'll come over here after my switch gets fired up and gets connected. Right now I'm not connected, so let me pause to see why it's not connected. Yeah, so the problem I had was my hub, which just wasn't, my switch wasn't firing up quite right, so I just unplugged and rebooted it real quick, and so now it's connected. I'm connected via wire. I could connect, this happens to be a wireless switch, so I could connect wirelessly. But one of the problems I had, I did have to connect, this one is on, this particular switch is on a 192.168.10, the 3rd decimal place in any type of home networking that you have. The default for the Sandevices E682 is the 192.168.1.206, 1 instead of 10, and it's a 206 fixed, and it's a fixed static address. So you need to be able to have something that's on the 1, and luckily most home systems are on the 1, and my regular home system is on the 1. So I had to go connect it to the home system and then wirelessly go in the first time I did this, and then you just go to your Internet Explorer and type 192.168.1.206, and it will pull up the Sandevices page. If you don't connect, you don't see this, you get no connection. But what I did to plug it into this switch that I'm using is I changed it to 10. So as you go along here, the first thing is you'll have an IP address that you can manually change the IP address and the card, and it will keep it, fix it in there. Also, most of my changes I seem to have to go through initially through my regular home router. So yeah, it's important to have that .1 to start with. There are some workarounds on the board, but it's just much easier to be up and running right away and have that regular home. So I changed the 3rd decimal here over here to 192.168.10.206. I left the 206. If you ever buy another one of these cards, you're gonna have to make it 207 or whatever. It'll keep talking. You can buy a ton load of these cards. I should mention that the E682 card will handle roughly 1,000 pixels or 3,000 channels, because every pixel has 3 diodes, red, green, and blue. A set of instructions, light intensities, and whatever. So that was what had happened. It'll do roughly 1,000 pixels, provided you provide enough power. And that's in the multicast mode. That's also a default that's over here. It's multicast, unicast, or some ArtNet. You can go unicast and get more, maybe 2,000 pixels, but it requires some additional setting up. Multicast just means if you have multiples of these, it'll send it out to all the information to all of them and disseminate. So the setup, the default is multicast. You don't need to change that. And I changed the test pattern. There was a test pattern that was running. You change it to 0, it disables the test pattern. And so you do that update system info and you reboot it. There's a reboot button way down the bottom of the screen. That's one of the times you have to reboot it. I didn't need to do a firmware. I was already at the latest firmware, but you could update the firmware here too. So yeah, the first time you change the IP, when you change an IP address, you don't need to do it to change the testing mode. But when you change the IP address, you have to reboot the card. Keep the same universes. The default universes are 1 through 7, and then some unicast. There's 8 through 12 out here. It's that 1 through 7 gets you, and on these cards you have 510 element controllers per universe. That's the magic number on the E682. So that's 170 pixels. So if you want to run a strand longer than 170 pixel lights, then you're going to be using up more than one universe. But anyways, if you do 7 times 500 is 3,500, and then you divide that by 3, and you can see you get a little over 1,000 pixels. That's why I'm coming up with that number. Just in the standard 7 universes, before you really need to go to another card or go to unicast. Down here, the 3rd section, the output configuration. Everything here, the third section, there's three groups, 1, 2, 3, and 4, and they have outputs 1 through 4 on each one of those groups. The third one is the default for the 28. As a matter of fact, 2, 3, and 4 you see here are all defaulted. They accept various types, but you can pull that drop down, and all you do is go and pull the drop down. I'm going to show you the first one because that's one I did change. I forgot what it originally was. Maybe it's 2801 because that's a common type also. But I changed it to the 6803 because that's what I have for that LED strip, the 12-volt strip. And that's the one I've got plugged into group 1. And I plugged my other 2811s into group 3. So I didn't mean to make any changes here, but all you do is do a drop down, and then over to the right on this there'll be an update. The other thing I needed to do after you get out there and you start testing is you figure out that sometimes your color order, red, green, and blue, are out. They were okay for my 2811s, but the 6803s they weren't. So I played around with a bit. I mean, there's only different, multiples of 3 there. And eventually green, blue, and red is what I needed to get that strip working. You can reverse the order here. It's not like the 3-wire, dumb LEDs where you could just reverse the green and the blue. You're going to have to play around in the software here. But you just do that setting, and now that strip comes up fine. And I left the defaults for the channels and the universes. If you really have a heavy display, you're going to have to change some of those defaults. And again, the magic number once again on the channels is 510. A lot of people say, oh, this is 512 because I think that's the old DMX number. But 2 of them are consumed in overhead or whatnot. So 510, and then if you do another universe at 511 to whatever 510 plus 5020 or something like that. And then you just hit the update button for that grouping, and it'll take a few seconds, but then it just pops into that mode, and all of a sudden, when I plugged it in originally, the strip, and it was under the other 2801, it would just light up all white for me, and eventually you'll get it working. So those are the big things that you need to do as far as setup. They're not drastic, especially if you're just using 2801 or 2801 or using standard pixels. I know that they have the GE color effects as a standard, and 3001 is another standard. So you'll restart the controller. But that's all you need to do is get that set up, and then get it, reboot it and get it talking. If this comes up, you're talking to it, you're in pretty good shape. So the next thing I'm going to talk about is the Vixen software, vixenlights.com. It's free software, which is nice. I have a couple different profiles because I did use this Vixen software for my Arduino setup this last year's Christmas and last month's Christmas. So I've got version 3 dot something. 3 is really nice because you have elements and groupings that really help you speed up some of that if you really want to do whole string. I know you have pixels, and you say, why would I want to do whole string when I have individual pixel control? But sometimes you just want to put groups together and make them flash all together. I know that sometimes those effects have to go that way. So this helps you out with the groupings. But what the first thing, one of the things you'll have to do, it doesn't really matter if you locate your controller or not. You can go to System and Configuration and set up elements and groups. And what I've done is what you do is do an add multiple, and there's this thing that comes up, and I just do, you can do any kind of naming scheme you want, but at the end of the day you're going to do like numbered items out here, and you'll generate 50 names because I'm going to do mine on a string. So I know I have 50 pixels on a string, and it happens in all cases here. I have 50 pixels on all 3 of my strings that I have connected right now. Remember, the pixel is an IC on the, I know there's 150 diodes on my 16-foot string, 6803, but there's only there's only 50 control points, 50. So you generate 50 of these, and you give it a name. And I used pixel SSS and pixel TTT and generated 50 of them. You'll need to generate all these, one for every element you want to control. In my case, it's pixel. So I did pixel SSS, pixel TTT, and then I did the 6803. So there's 150 entries there, and that's okay. I don't know if that's the best way to do it or not, but I like to have. I always like to have those because what you can do is highlight a selection of them. So I can highlight all the 6803s, and then I can group them. And I've done that down below down here. I have string 6803. And now they're in a grouping, and so they'll explode, and I'll get another copy, And in the software, you can, just because I put a pixel in this 6803 grouping string, I can use it in other strings too. So if I had a star design, I can do 5 pixels. I can make that star number 1, star number 2, and I can flash that whole star at once very quickly, as opposed to going to every single pixel in that star and setting the color, especially if I want to use the same color at the same time for the same duration. I'm going to do some kind of nutcracker effect, which is what Vixen's pretty good here too, rather than if I'm going to do a chase sequence on it or something like that. Rather than timing every pixel, it'll group them together as 50 pixels for a string here, and you'll see that in a bit. And so I've done some grouping, so it allows you to group like that, so you take advantage of that. You have to put a little bit of thought into these setups and your pixels, but once you have all those, you do okay, and you can actually go forward and program right now. But I am going to show you the controller setup, because you can, once you got your element set up, there's a pixel has the Vixen has the setup previews, and you can set up your previews and see it visually there, as opposed to using a controller with the lights. Or you can just start doing programming, which are sequence programming, even without because you can switch your controllers later. The next thing you have to do is go set up your controller. And the setup controller stream looks like this. So you do add a new controller. I've got the streaming Vixen E1.31. That's what you're going to want to use for these pixel controls. I did have, let's see, the Arduino, and all you do is select an item. Arduino is a generic serial, and the USB port. I probably will use that in next year's. I'll just plug it into the USB port in the computer here, and it'll go run my Arduino setups with the hard relays, and I can get more lights, unless I go all pixel this year. We'll see. Pixels are a little expensive, like I said. But when you click on one of these, it'll save your controller. I bumped the channels up to 1,000. Obviously, if you went to 3,500, maybe that would get you your full universes. You wouldn't have to worry about it again. But I just got a couple. I've only got 150 ICs out here, pixels, so 1,000's fine, even in different universes. You have to do the configure controller button, and this is important. Screws a lot of people up, is that I've just got 2 setups here because I have 2 different groups. So you need to know what universe each is in. Again, this was back on the Internet Explorer. I should have explained real quickly that where the universes is started and finished. So this is where that 510 comes in. A lot of people they'll go ahead and create the universe sizes of 510 out here, but the starts they'll leave, the default is 1. So they'll have universe 1 or universe 2 or universe 3 or 5 or whatever. They'll have the same starting, and then they can't figure out why their strings don't work. So make sure that you start the universe on a number higher than what the next one is. Also over here, it gives you some choices of each universe for a drop down, and your choices are, for me, are LAN connection 2 or wireless as a third connection in there. But make sure you pick the right one that you're on. If I'm on wireless, I can run this on wireless. You're on wireless. If not, you're on the LAN. And also make sure that it's in use by using the check mark in here. So I've got 2 universes here, starting at 1 and starting at 601, and they're both on LAN 2. So make sure whenever you have a problem, go back to this controller setup. And that's it. So the next thing you want to do is go over here, again, the system configuration, and set up your display. I think I click that. And so this is your patching. So over here you have the individual pixels. Remember, we set those up. I also set up groups. But what you want to do is highlight all your pixels, all the 50. So you use the shift key and you go down. And then after you highlight the 50, you come down here where it says configure dimming curve. You actually want to configure with color handling. Select color handling, and there's a button next to it called configure, and you hit configure and it'll say, hey, configure for color. And the end result is that each one of these pixels, if I click on this one, it's got 3 total patch points. Otherwise, if you don't do color, you only get 1 patch point. And so it's important, you go highlight all of them, and so if I do 50 here, 50 items, I'm going to get 150 total patch points. And then you'll come over here to the outputs on your controller, and this is only when you have the controller, you know, in stream set up. And you'll select, I think I started at 180 was my in use, 181. So actually pixel, let me go back and click the first pixel, because I've already done all these. You select all 150 here on the left, in other words 50, select 50, you get 150 patch points. Then you select 150 contiguous over here, and your outputs will be 150. I know there's 0 right now and 3. There's a button down here that'll light up called Patch Elements. And you'll push the patch elements, and it'll patch those 50 points, or 150 patch points, 50 elements, 150 patch points to those 150 outputs. And we had set that up on the controller, because remember my Universe 3 started at 181 over on the internet setup page. So that's why I started at 181. And you know, if you don't get it right here, they just won't light. And you keep going, you know, do a little test and figure out, and you'll learn the setup pretty quickly. So my first 2 strings went from 181 up to that should be 480. That's 300 total patch points, which is 100 bulbs, which is my 2811s. And remember I said 601 was my universe that I started with. So I started patching at, because remember it started at 1, and I don't know why it was 181, because I was plugged in. I know why it was 181, because I was plugged into the 3.1. But 601, again, this is universe 1. So you can play around with that. And it's a little confusing, but it just, you know, keep picking till you get in the zone where you are. Worst case scenario, if you can't figure it out, then just go back to your setup and on the E682. And after you're done with those, you'll have patched all the outputs. They'll all turn green on you, and then your controller ready. So that's the big 3. You can set up a preview, and what you can do is take a JPEG of your house and start to draw in lines so you can see it on the screen. You know, and so you don't have to wait till it's out in the yard to kind of figure that kind of stuff out. You can draw all kinds of fancy stuff. But I'm going to go here, and usually you create a new sequence and do a timed sequence. That's usually what I do. You can do a data sequence, but my latest one is here. And so I'm going to open a sequence. Of course, after you save a sequence, it's open for you. You definitely want to turn on your autosave and save frequently, because the program could crash once in a while. What comes up in your sequencer is exactly what you saw in the controller list. I've got all these individual pixels. I think for, you know, I could start the program there. But let me go all the way down the bottom, because that's where I've got my stuff, string 6083, string 1, string 2, and a bunch of trees. I've got my pixels set up on this styrofoam board, and sort of like trees. I know they're real narrow. I would space them out better in the real world. But so if I go ahead and start the program, you'll see some flashing and you know, going through the string and lighting it up full. And then I've got these tree sequences with the stars kind of blinking, and I've got just a whole bunch of nutcracker adds. It's usually nutcracker is a pretty important element that you can add to this string, and all it's doing as it's running along here is you know, you just create blocks in these areas, and there's a lot of film for how to do that in Vixen. But yeah, so I'll eventually put this to music. I just did random 10-second patterns, or not really random, they're programmed, but I'm using the nutcracker to generate lots of effects very quickly. I can do it pixel by pixel if I wanted to, and I had the time. But for the setup, I just want to make sure it was working right. And so, yep, everything looks like it's going along good here. I'm fading, I'm doing the strip. So down here at the end, you saw this was like a chase. And so, you know, if you're on one of these strings, you just do a right click, add effect. And nutcracker is a very nice one. There's a whole bunch of series of nutcracker ones. Chase is nice. Candle flickering is nice. You saw a little bit in there. Let me do a little nutcracker one, or let me do a nutcracker. And within nutcracker, now it would turn that whole string this. You get, you know, you double click on it. You can change it from, you know, all kinds of stuff. This is where your megapixel trees and stuff that you want to set up. You could do that. I can make a fire effect. I put it for horizontal line because mine are all in horizontal. You can see what it's doing, a little preview. You can change the colors and the speed. I cancel out of that because I don't really want to, well, I already created it. But that's how easy it is to do individual type things, and you can see I fade them to color. You can do gradients and stuff. This is just one element, one block, controlling, timing out 50 items. So it's kind of an easy software to use, and it will run right off it. So eventually I'll buy some more pixels and keep adding to this system. I'll figure out if I'm going to do 5 volt or 12 volt. Actually, the 6083 came out a lot better than I thought it would as far as an LED rope lighting. So I kind of thought these pixel bullets are 12 millimeter or ½ inch, so I just poked ½ inch holes in the styrofoam. Obviously if it was wood, they would stick a little bit better in there. But let me just run it again just to get an idea that we're running from the start. F5, just a chase sequence out there. This is all full white. This would be full power draw. And I usually do a little bit of a test routine that tests the first and the last in the series to make sure that I've got the right 150 patch points assigned to the right elements. And if you get it wrong, you may notice that you can test it that way. You can turn them all on, but you can turn the first and the last on in a string and what you think be. And if you don't see the right numbers, then it is what it is. You have to go back and reconfigure your controller. But yeah, it's really interesting to see what people will do online. And I don't know if I'm going to with this Christmas tree pattern necessarily, or circles. I saw 4 circles. That's a nice one to look up. Matt Johnson Family Christmas was one of the inspirations I saw this year when I was doing YouTube videos and setting up the Arduino. I said, he's got kind of a slick with this pixel stuff. It's a little bit, well, it's pricey, but all Christmas stuff is pricey, and this looks like it actually in the long run might be a little cheaper, especially when you expand the system. Certainly a lot cheaper than the Lightorama, and a little bit more expensive than some of the crazier ones, but it's pretty powerful what you can do with this. So good luck with your future displays, and hopefully this will, either if you're on the fence or you don't know what it is, hopefully this will motivate you that this is something that you can kind of do in your house, and people certainly enjoy it when they drive by or stand outside. It's something that they can. I know it takes a little time to sequence these and put it in the music. I didn't have the music in yet, but not too bad. And certainly you can schedule the shows in the Vixen, so it just comes on automatically and runs 4 or 5 sequences in a row, and then just goes back to some, like Christmas trees or something. So yeah, hopefully this will motivate you.